Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about Russia's Lunar 25. So let's dive deep into it. Now Lunar 25, this puppy was launched on 10 August 2023, very recently, and time was 23:10 Universal Time Coordinate. This puppy Soyuz 2.1b and Voskhod Cosmodrome, basically normal known place, and it's supposed to be, let that be very clear, it's not in competition with basically Chandrayaan 3. It's irony that it came so close. It's supposed to be launched in 2021, so it's ludicrously behind schedule. Like, this puppy is behind, as in not just like a little bit. No, this puppy is behind schedule. Like, the history is far more interesting than the payload and all that. This puppy is basically supposed to be a successor of Luna 24. Now, this was a probe of USSR. Now, USSR did try to send man to the moon, but they went boom. And after that, they did try to have a sample return mission, which they did try. And if many times people ask, like, how do you know Apollo missions are real or not? Don't argue with them. And there is just a nugget of truth is the fact that when Apollo missions were happening, that footage was being captured on the surface of moon, there is a shiny thing going there, and people thought, nobody paid attention to it. And after they paid attention to it, it's like, wait a minute, it's the orbit does not make sense. Then it was realized it was a Soviet probe. They did not announce it because their idea was like, only if we get it successfully, then we're gonna claim that we beat them in order to sample connection, which it did not work out. It did went there, but it crashed, and they had to do it multiple times. Landing on moon is difficult. And this is another thing, is like, in my last video, more than one people have commented, is like, if landing on moon is so complex from an algorithm point of view, how the heck they did it in, like, back in the days? It's like they forgot, like, Apollo mission had this puppy, a human looking lion is like looking like this. It's like, I'm landing it. Like, they spend it, like, you can watch the footage, landing footage, and everybody was scared. It's like, dude, it was like, and they were running very close to running the fuel in dry. That would have been a boom state. So it was a very dangerous thing, even back then, even with a human pilot. So they basically continued this probe of Luna 24. However, because they were communism, and communism always goes boom, their economy went boom. And after they went boom, this sort of expensive project was not sustainable. However, this project was the last like, hurrah, so to say. 9 August, again, it was also launched in August 1976. Yes, this is ancient, and they launched it. They collected 170 grams of sample. This ramp that you see, that was the use of it. Collect the sample, pack it in a small rocket, and yeet it back up. And yes, it did work. They were surprisingly good at it. Like, sample return, lunar sample return, they're like, bro, we got this. We can do it multiple times. 3 times, if I'm not mistaken, they have done that. So they did that. However, after this thing happened, Soviet Union went poof. The Russia did not have the same financial backing as USSR, so they had to be very cautious. So project was created, but it was always like, let's be cautious about that. And then they went to Japan. The idea was that they're gonna provide the rocket part of the equation, and Japan is gonna provide the electronics part of it and the, like, payload part of it. That did not work out, and that collaboration was scrapped in 2007. After that, they started to collaborate with India, ISRO. This happened with our Prime Minister visit there. And this is not Narendra Modi, this is Manmohan Singh, before Narendra Modi. And during this conversation, this visit, the idea was created that ISRO and Roscosmos should work together. Now, it was a very bit weird shock to Roscosmos because they did not know they're supposed to do this. Consequence of that, the project was redesigned way too many times. So original design is supposed to look something like this. So they had to redesign multiple times, and that reached a point where ISRO was like, bro, this is not going anywhere. You are not happy, we are not happy, neither you are winning, neither we are winning. So let's just call it off. That was called off in 2014. So yeah, that's the history part of it. It's quite ironic. They tried to make it work so many times, but because of low funding, because of poor partnership, poor clear goals, it never, like, materialized. This puppy should have been done long ago, not in 2021, as in like 2010 kind of long ago. It should have been done long ago. So what sort of instrument this puppy has? Well, this instrument package has been readjusted so many times, but as of now it has LASMA LR, laser mass spectrometer. Then they have ADRON LR, neutron and gamma analysis instruments, and then you have ARIES, plasma for exospectrum. Be mindful, anything that is in space and generally classed as a celestial body does have atmosphere. Like no matter where you go, it does have atmosphere. It's just atmosphere density is the question, how dense it is or how faint it is. In case of moon, it does have atmosphere but super low density. So they need a dedicated instrument to analyze it, detect it, and study it. So this is why they have that. And then they have LISTV, RPM. This is an imaging system that also will do infrared spectrography of the minerals that they're gonna collect. And they have PML, which is dust and micrometeorite study analysis. Because be mindful, while we do see moon, while we do see craters, we don't actively see it so many times where it's like, oh, this happened, that happened. It's very rarely seen. That being said, the things that we see is generally large things. Small things are happening all the time. Basically, there is a rain happening. It's all the time things are happening. Dust cloud is being created. It's very faint, very subtle. But if you are there for long duration, let's say you landed someplace and you studied it for 1 year, you will notice it. So they have a dedicated instrument for that sort of thing. And then they have thermal L, which is a thermographic properties. They're going to study what is the thermal behavior of lunar soil or legorith. And here's the deal. You may be like, many of these things require collecting something. Well, to solve that issue, they have robotic arm, this puppy. And this is the scoop. Scoop is almost this size. They're gonna scoop it. And the idea with the scoop is also very clever because it physically cannot move. Once it lands, it's done. So once it collects the scoop, not only is going to study the sterilized part of the surface, subsurface, basically the part that has been exposed very recently, it would be very fresh. It won't be sterilized by solar radiation. So they want to collect data there. And the expectation is we're supposed to see a bit more ice there. Like, be mindful, Soviet Union did collect soil from moon and they did brought it back and they did detect water. So that's why they are having high hopes that when you do it, it's actually should be like, no, we are detecting it, not like a little bit, 1 microgram or not, like we are detecting. That means if we actually send a settlement there, hopefully in principle, we should be able to collect enough water to be useful, hopefully. So these are the instrument way. You can see that like this is a big puppy. So that should create a question in your head. It's like, okay, you have so many things. How the heck you are powering it? Well, powering it is very difficult given this place. If you send something to Mars, it's not that difficult because you have day and night cycle, meaning your battery does not have to carry over for much longer. But here, lunar surface is brutal, especially with temperature. Why? Yeah, the daytime is bit hot, like not that hot. It's like 120 degrees Celsius, meaning you are slow roasting anything. And then you have night, which is a bit cool, not too cool, but a bit cool. That is minus 130 degrees Celsius. Yeah, and that itself is not that bad of a deal. The worst part is 15 days of it, meaning when you are being roasted, you don't have the cool down period that is just around the core, just around the orbit. Basically, how satellite survives with it is like satellite will be in the sun, it will cook off, then it will go into shade, it will cool off, cook off, cool off, cool off, pull off. It does put thermal cycling onto them, but does help them. It's like, hey, instead of getting too hot or getting too cold, it does help them. Here, you will get hot, and then in cool part, you will get cool. That's a really brutal thing that is amplified by 15 days continuous. So it needs a lot of power and it also needs a lot of insulation. Insulation is the only way they can endure the slow roasting and survive the slow freezing. So they have solar power for the day. That's why you can see solar panels, and those will allow them to run the heavy loads. Basically, all the communication equipments, all the instrument and robotic arms. Then they have top radiator, this shiny thing. Now you may be like, why the heck a radiator is shiny? My best guess is that it's supposed to be exposed to the sun in worst case. Let's say it landed somewhere where the sun is directly shining on it. If it would have been black, it will cook the puppy. So they are like, let's make it shiny. It does reduce efficiency a little bit, but it's more than good enough, and I'm pretty sure it will do its job. So it will cool it off in daytime. But what about night? This will backfire in night. To solve the night, they have RTG, and RTG will provide enough power, electrical power, so it can remain in communication and do minor things. My expectations is I do not think they will use robotic arm, or if they have to use robotic arm, they have to shut down way too many instruments. So night load, low load. Basically, for 15 days, it will like a high yield science will happen on the daytime, and low yield science will happen in night time. And then just to make sure that they can actually survive the night, they have RTGs. After the RTGs, they have radioactive thermal heater units, basically this puppy. Now, this is an American unit. A Russian unit will look more or less the same. It has a very radioactive plutonium or something similar, where it's encased into graphite, and that is encased into whatever suitable material they can choose. And these are placed strategically to make sure the temperature never goes down too low. Basically, it dumps enough heat that temperature delta does not become too extreme. Basically, you will start to cool down. Let's say worst case happened, 120 degrees Celsius. Like sun is about to go down below the horizon. You are at 120 degrees Celsius. Now your heat will start to escape very quickly because it's 120 degrees Celsius and night side is minus 120 degrees Celsius. A lot of heat flux is happening. But at a certain point, once your temperature has dropped, let's say to 20 degrees Celsius, delta is shrunk. Insulation will be like, I got this, I can handle it. And then you have a little bit of positive energy flow from not only from RTG, but from these units also, meaning you can survive the nights without too much hazard. If designed properly, if calibrated properly, this puppy should work just fine. For longer than a year, this puppy should just work just fine. Hopefully, that's the hope, because we meant for 15 days, 15 night is brutal. So many people are comparing this to Chandrayaan 3. Now, mission profiles are different. You have to understand what ISRO is trying to achieve is completely different from what Roscosmos is trying to achieve. So comparing them is like fundamentally wrong. And many times people are not focusing on the history. That it's sad from Roscosmos' point of view that Chandrayaan almost became a point where it's like, dude, they will become the first thing to land on as close to South Pole as possible. So what is the limitation of Chandrayaan? Chandrayaan has much smaller power envelope. How much energy it has available to it, it's very less. How can it survive the lunar nights? It's not impossible, because we might, once it starts to cool down from hot side to cold, once the temperature delta becomes low enough, low extreme, it has insulation, it should survive, it could survive. But consequences, the hard part would be once you have really cooled down, like your temperature is at close to equilibrium as possible, the daytime would be cooking you again. So thermal shock could be brutal. You could literally have such a brutal thermal shock. Your PCB could expand more than the ICs, and ICs could desolder. So yes, it has happened to satellites. So we have learned it the hard way, that you have to make sure the thermal is equilibrated, so to say. So it's very difficult. That's why they are targeting one lunar day. Can it survive a lunar night? Not impossible, but likelihood will be very low. So we could have a magical scenario where it's like, oh, it just works in the next day also, as in like after 15 days of silence. It has happened with basically Mars helicopter. However, that puppy was in a much more pleasant environment compared to the moon surface. Temperature, night temperature and day temperature was not that extreme. Now, it also has a rover, a tiny rover, so that also adds some level of complexity. Now, span, this is where the core design difference is. This puppy is designed for one day, basically one lunar day, as in 15 days of Earth time. Now, Russian system is designed for one Earth year, 365 days, 12 months. That's the minimum life expectancy. So, a completely different ball game. That's why it has so many instruments. All the instruments that are like collect data very slowly over time, they need some static base where they're like, no, I'm going to keep collecting instrument data over basically a year. Only then they can give you some, quality of data, so to say. And ISRO is basically trying to prove that they can do lunar landing. We have tried this. We had Chandrayaan 2. If it had worked, we would not be watching this video. Chandrayaan 2 almost worked. The base part did work, and the landing part software algorithm did not work out. But here still, that's how you learn. When I'm saying ISRO, USSR did lunar landings, they had lot of crash. Like look into it, like a lot of crash. So it's not a like oh, ISRO is not doing it. It's like they are doing just fine. You're not supposed to like get in there in one go. It happens time to time, but not all the time. So ISRO is trying to like, hey, we have learned how to make a landing algorithm on a complex terrain. So they're gonna get there. And Roscosmos is fighting for budget. Be mindful, because we see Roscosmos actually launching astronauts, we think that they are solid, they are loaded in terms of money. They are not. They are carry forward from USSR era. USSR poured money like there is no tomorrow. But look into Russia's economy, it does not have that kind of wealth, and all the wealth is focused in oligarchs and all that jazz. So they do not have richness as you need in order to have a thriving space economy. And look into their rockets compared to the Soviet Union era, compared to now, it looks almost the same. The reason for the same is like improvements are very minuscule, and half of the improvements were planned out long ago. They just took so long to deploy. So it's not like oh, they're rich, they're loaded, they're doing research and all that. It's like very minuscule, like very, very minuscule. On top of that, they were literally trying to ask Japan. Think about it. Like they had to go to Japan. It's like, hey, can you help us out? They do not have the money. The only reason they have money is ISS, International Space Station, because that gives them a fixed contract. They have something. So they are fighting for a budget, and many people pointed out, it's like it looks like a last hurrah of the great Soviet Union. So completely different. However, whichever lands, whichever collects the most data, lunar research will win anyways. So we should be happy about that. Like lunar research are winning. So let's be happy. And be mindful, ISRO is just getting started. Roscosmos is in a position where their finances are not good. Not good. So this was my presentation on basically Lunar 25. Hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.